This podcast is brought to you by Ocado Technology, a division of the Ocado Group that builds the software and systems powering Ocado.com, the world's largest online-only grocery retailer. We've been disrupting the grocery industry for over 15 years using the cloud, robotics, AI, and IoT. Find out more and check out career opportunities at infoq.link/Ocado.
Welcome to the InfoQ Podcast. My name is Wes Reisz and I'm your host. In addition to hosting the InfoQ Podcast, I also get the crazy privilege to chair a set of software conferences called QCon. QCon, brought to you by InfoQ, is a conference designed for software architects, tech leads, senior developers, and technical engineering managers. We are a senior software developer conference featuring the practitioners on the keyboards pushing the PRs and the leaders driving the change at places like Google, eBay, Netflix, Twitter, Ocado, Skybit, and so many more. If you're looking for what's next and you want to learn from the successes and more often the failures from some of the world's largest software shops, I hope you'll check us out. If you do, please stop me and say hi and let me know how we can make this podcast so much better. Today we're talking to Sander Mak. Sander is a fellow and software architect for a company called Luminous in the Netherlands. He's been working with Java for well over 10 years and recently was the co-author of a book on Java modularization or Jigsaw called Java 9 Modularity, Patterns and Practices for Developing Maintainable Application. On today's podcast, Sander and I discuss the module system with the recently released Java 9. We'll hit on some of the practical advice he's been preparing and discussing with engineers on their migrations to 9 with and without the class path. We'll discuss some of the benefits and pitfalls as you look to plan and execute your migrations. And if you're already on 9, we'll chat a bit about what to expect with the reality of living with JDK 9. One thing to note, as you're no doubt aware, Java has moved to a 6-month release cadence. That means as this podcast is being released, Java 10 has been out. Unfortunately, this podcast was recorded prior to the release of 10, so much of the vocabulary you'll hear is focused around 9 and not 10. Finally, thank you so much for choosing to spend your morning drives, your gym time, your runs with us on the InfoQ Podcast. Thank you for joining us. Sander, welcome to the InfoQ Podcast.
Thanks for having me, Wes.
So September 21st last year, JDK 9 was released. It offered a lot of different benefits, like G1GC became the default garbage collector, the REPL. There were benchmarks that showed faster implementations with 9 over 8. HTTP2 is there, but the big thing, the 800-pound gorilla, at least in my mind, was the modularization system. It sort of broke up RT.jar into kind of like following this trend of decomposition. So what I wanted to do today was talk a bit about the module system and the whole experience that you've seen people kind of going through. But before we do that, it wouldn't be fair not to at least mention some of the other things with JDK 9. There's something like 90 different JEPs, I think, that were part of 9. What are some of the other things within Java 9 that you think are particularly poignant or important for developers to pay attention to?
Like you said, the module system turned all the eyes and was the big feature of Java 9. But what I really like about Java 9 is some of the API enhancements that have been made. So, for example, you already mentioned an HTTP2 client API, which unfortunately isn't production ready yet. It's shipped as an experimental API, but it will be an official HTTP client for Java in Java 11. And the other thing that I really like about Java 9, besides all the bigger features, is a simple small feature called collection factory methods. So we all create collections in our code, and we have to create a collection. We have to choose an exact implementation that we're going to instantiate, and we add elements to it. And there's a lot of code, lots of thinking. Now we get nice little factory method called setOff or listOff, and you can just pass in a variable number of elements and you get back an immutable list of that type. So that's a really cool, nice thing that you will use almost daily. At least I use it a lot. And these little things, there are lots of those in Java 9. So besides the bigger features that we just mentioned, I really like the fact that Java is moving forward and that we get these nice things as well.
I think last time I looked, there's something in the neighborhood of 6 million Java developers out there. We'll say not all of them are on Java 9 at the moment. What are you seeing or hearing about as far as adoption with 9 today?
Yeah, so I think it's pretty safe to say that a minority of these 6 million developers are currently on 9. We had a lot of people jumping to Java 8 pretty quickly because people saw Lambdas, people saw Streams, and those were really great and compelling features that you could use right away. So with Java 9, the story is a bit different. We had to wait quite a while on Java 9, of course, and the big feature of the module system, it's really on a different level than the Lambdas and streams that we got in Java 8. It's much more about the architecture and design of your application. It influences the tools that you use. So this altogether is a feature that takes much more time to bake in the community. So in that sense, it doesn't surprise me that people aren't jumping on Java 9 like they were in Java 8. Also, what doesn't really help is that Oracle has decided to move to a more frequent release schedule for Java. So we will get a new major Java release every 6 months now, which means that Java 9 will already be replaced by Java 10 in March this year, which is really quick, of course. So this whole new reality also needs to sink into the community and into all development teams, and people need to find out, okay, how are we going to deal with this, right? Because in September, we're already getting Java 11 and the train will go on. So people are sort of waiting it out, in my opinion. And that's unfortunate because the change from Java 8 to Java 9 is quite big because of modularization, but also because of lots of different features that have been introduced. It's a large release. So if you're not checking it out already in your development stack, in your development environments at least, then I think you're doing yourself a disservice, because when you're going to move to a newer Java version, be it Java 9 or 10 or 11, you'll run into the same issues that you can tackle now when you move to Java 9.
Yeah, that's a really good point. So as you mentioned, with moving to 8, you had Lambdas and you had streams. So there was a lot of tangible things for developers to get a hold of and be able to use in their code. So there was kind of a lot of momentum to drive people there. So without that, what does modularization really give us? What's the real benefit? Obviously, it makes things smaller, but why is that so important?
Well, I don't think the essence is actually making things smaller. I think the essence is making things more manageable and maintainable. So modularization is really an architectural principle that you want to apply when you have larger code bases. What you typically see when people start out with a project, you've got a few people coding, you've got a nice team starting up from a blank slate. Everything's going well and features flow. But after a while, you hit a brick wall. Your code base grows in complexity, maybe after a year, maybe after 2 years, maybe after 4 years, but there will be a point when it becomes harder and harder to maintain a code base, to add new features without breaking stuff all over the place. And this has everything to do with the fact that it's just hard to really modularize a code base correctly. And of course, people had tools already to do this in Java, and if you applied them consciously, and if you were really aware of all the principles behind them, you can get a long way. But the module system now also offers some native constructs to help you encapsulate code, because encapsulation is really an important principle. If you think about modularization, it's about hiding stuff. If you hide your implementation details and only publicly expose your APIs, that goes a long way in making sure that people won't abuse your internals, for example. And also the fact that with modules, you have explicit dependencies between different parts. So modules explicitly state which other modules they need. And this knowledge can be used by all the tooling, by the compiler, by the runtime, etc., to check whether everything's in place. And it's really an improvement over the old classpath situation, where if you threw a jar file on the classpath, first of all, it wouldn't have any dependency information. So you could miss a jar file, or you could have multiple jar files, and it would blow up at runtime. And the other point was that any public class that is in the jar file will be visible to any other public class on the JVM in the class path. So there's really no encapsulation, there's really no enforcement of public versus private APIs. And this is something that modularity actually brings to the table. So this will help you creating more maintainable software. It will help you create more reliable software, in the sense that you will be sure that when you run a modular application, that the JVM and that the module system can check for you whether everything's in place, rather than just hoping the class path is configured correctly. So these are the most important things when talking about modularity and Java development.
But, the things you just talk about are very greenfield. They're like positioning yourself for the future so that you have a more maintainable app. If you're running on 8 today and you have a system that is running, none of the things you just mentioned really are a reason or a benefit for me to move to 9. What are some of the benefits that my 8 code base can gain by moving to 9? Like, is it faster warming up? Is it easier for cloud deployments? Is there less of a attack surface because any of the libraries you're not using, like Corba, for example, isn't deployed? What are some of those things?
Yeah, so definitely if you're starting using the module system, that's really a greenfield situation. It will be hard to migrate large code bases to modules as is mostly. So if you have an existing code base on Java 8 and you're going to Java 9, you of course get all the performance benefits. So we get a new garbage collector by default, which is much improved in Java 9, the G1 garbage collector. There are also improvements to, for example, string performance in Java 9. So we get compact string representations. If you have lots of ASCII strings in your code, then this will be noticeable in the overhead on the heap. So these are all things you get almost for free, right, when you move from Java 8 to Java 9. In addition to that, like you already mentioned, because the JDK itself has been modularized as well, you do get the benefits of the fact that some obsolete technologies like Corba and some Java Enterprise technologies that were traditionally shipped with Java SE are now deprecated, and they're deprecated for removal. So they will be removed in some future version of Java. So they won't be in your way anymore on the class path. But that also has a flip side, because they're not there anymore. If your application did use them, you have an issue when moving to Java 9.
So we just talked briefly about greenfield apps versus migration to 9 from 8. What are you seeing in practice? Are people that are making the migration from 8 to 9, are they moving to 9 and keeping the class path? Are they going deep, going through and actually modularizing their code base?
Yeah, so what I'm currently seeing mostly is that people are migrating to the class path in Java 9, because that's what people know, that's what people are familiar with, and that's also sometimes already challenging in some situations. So if you've got an application running on the class path in Java 8 and you're going to 9, you will have some migration challenges ahead if your code, for example, uses APIs that have now been encapsulated in the JDK, for example. Or if you're using some of the Java EE technologies that were usually shipped with Java SE and they're not available by default anymore. So these are issues that you run into, and those are all solvable issues. We can talk about that. But of course, once you've done that and once you're up and running on Java 9 on the class path, then the next question, of course, is, so should I move to modules as well? There's no one-size-fits-all answer to that. If you already have a code base that in and of itself has a modular and broken down structure, then it will be quite beneficial and also feasible to move to modules as well. On the other hand, if your application is one big jar with sort of spaghetti code, to say it in a
nicely
not so flattering way, then you will have a hard time adopting modules, because modules aren't just a magic language feature where you sprinkle in some keywords. It's about the really hard part of breaking down your code base into manageable pieces, into independent pieces. And that's not something that a language feature can magically do for you. So that's definitely a case-by-case decision that you should take.
There's a new tool that's available with Java 9 called JLink that can help you with your module path. What exactly does JLink do, and how does it work?
Yeah, so JLink is indeed a new tool that's been added in JDK 9, and I think it's one of the really cool applications of the module system. So what you can do with JLink is you can take your modular application and you can point it to your root module, so the module that starts your application, and you can tell JLink to create a custom runtime image. And a custom runtime image is almost like a custom JRE containing your application modules, but also the modules from the JDK that your application needs to run, but only those modules that your application needs. And this is all based, of course, on the metadata, on the module descriptors that are in your application. So JLink can find out what's the module graph for your application, up to and including the specific modules from the JDK that you need, and it packages this up into a distributable JRE, so to say. So this is a really nice way to create a stripped down Java distribution containing your application. For example, if you have a desktop application, it might only contain the Java desktop module and its dependencies and your application code, and it won't contain all the old Corba stuff, etc., that we talked about before. So if you have a simple Java class which only uses types from the Java base module, which is the sort of root module in the JDK, then you can actually get a complete runtime image of about 20 megabytes, which is much, much smaller than distributing a whole JDK and your application on top of that. Yeah. And the nice thing also is that during this linking, also some optimizations can be applied across all modules. So this is sort of like a whole program optimization opportunity that we now get that we didn't have before. So I do think that JLink is one of the really cool applications of modules, but it does require your application to be modular itself.
So you mentioned some optimizations that JLink. What kind of optimizations does it give you?
So one thing it can do is it can create a cache of all the module descriptors of your modules that are in the runtime image. So it doesn't have to parse those at startup time anymore. Another thing that it can do, and this is quite low level and technical, but it can also pre-generate some classes for quicker Lambda invocations. And in this way, it doesn't have to generate at runtime some of these classes that are necessary to execute Lambdas. And there are potentially many more optimizations, but Java 9 had to ship, so these are not implemented yet. But JLink is plugin based, so you can even plug in new optimizations later.
So let's take a use case. And I think at KubeCon London here in March, you're going to actually do a deep dive, 50-minute talk that specifically outlines this. But let's kind of take maybe a little bit higher level and kind of preview the talk maybe. But let's take an example. So if we take a kind of a typical Java application, maybe a Spring Hibernate solution, Spring DAO or something like that. If that's your application, you're running on 8 and you want to go to 9, what do you need to start thinking about? What are the first steps you need to think about? We just talked about not classpath. What does that mean? Is there a structure of the JDK changed? What are some of the real first steps that you need to think about as you're getting ready to port to 9?
The first thing that you should do when moving to Java 9 from Java 8 is take your existing code and just try running it with a Java 9 JVM. And a few things could happen there. First of all, if your code, for example, uses Spring or Hibernate, these frameworks in turn use types from, for example, the JAX-B implementation that used to be shipped with Java SE. And these are by default not resolved anymore when running code. So, like I said earlier, some of these Java EE technologies that were shipped with Java SE are now in separate modules, and these modules have been deprecated for removal. And when you're running or compiling on the class path, they're not automatically available anymore. So that means that you have two options there. On the one hand, you could add these modules to the resolution process using a command line flag, and things will work again. They will appear to your other code, and you can compile against it, and you can run against it. But of course, that's not a really satisfying solution because we know these modules are going away in future Java versions. So the other option, that's actually the best solution there, is to go out and select your own implementation of JAX-B or the JAX-WS standard or whatever it is that you're using and add that to the class path. So that's one class of issues that you can run into. The other one has to do with actual deprecated and removed APIs in Java 9. So for the first time in a long while, actual deprecated methods in some parts of the API have been removed. Just to be fair, these removals are fairly minor and in APIs that are not that often used. So I don't think many people will run into this, but it's a possibility. And in that case, you will have to change your code. There's no way around it. Another issue that you might run into when running Java 8 applications on the Java 9 class path is that they might use APIs that have been encapsulated in JDK 9. Encapsulated means that the JDK itself has been modularized and modules can have public parts, exported APIs, and they can also have encapsulated code inside of them. And this encapsulated code cannot be reached from outside the module. And of course, there's a perfectly good reason for that, because that's what allows us to evolve a module and independently evolve the implementation without breaking clients. But because Java for a long time has been wide open, so to say, so you could just use any internal or private APIs of the JDK, mostly libraries, they use those private parts. And actually, some of the dependencies of Hibernate and Spring do try to hack into the private internal implementation details of the JDK classes. So this will work on Java 9 by default on the class path. But you will see a warning when that happens at runtime. So you will get a warning printed to the console saying, so there's some illegal access happening to an encapsulated type. So the code still runs, but you see that something's up there and that you need to fix it. Again, there are several approaches that you can take to fixing this issue if you see such a warning. First of all, the best way to solve this is to actually go to a library maintainer of the offending library and see if they actually have an updated version of this library that doesn't use the encapsulated APIs anymore, because this is what needs to happen. All libraries need to move away from using these internal implementation classes. And in the case of many of these dependencies for Spring and for Hibernate, this has actually happened. But that does mean that you need to move to some different versions of jars and dependencies. And that might not always be what you want or what you can do right away. So in those cases, there are some flags in the Java 9 JVM, the add exports flag and the add opens flag, which you can use to selectively open up encapsulated code of JDK modules. So they will still be available to the libraries that want to use them.
So you mentioned third-party libraries. Obviously, one of the challenges that someone might be thinking about right now are I can go through and modularize my code, and I can use libraries that may use modularized code, but that doesn't mean they're not going to have a transitive dependency to something else that isn't modularized. So how is that resolved with Jigsaw?
The first step that we talked about is moving from the Java 8 class path to the Java 9 class path. And once you've done that, you can start using modules to modularize your own code. And indeed, you will run into libraries, dependencies that you have that aren't modules yet, that don't have a module descriptor explaining their exports and dependencies. So to acknowledge this, a feature was introduced in the Java module system called automatic modules. And what it does is that you can take a jar file from the class path, and this jar file is just a plain old jar file. It doesn't contain any Java 9 specific metadata. It doesn't contain a module descriptor. But you can put it on the module path, which is the new container where modules live. And it will be treated as if it is a module. And it will get a name. And this name is derived either from the file name of the jar file or derived from a header that you can set in the meta-inf manifest file. And this name, you can use it to refer to this automatic module from your own modules. If you require that automatic module, you use the name that's been generated for the automatic module. It behaves as if all packages that are in the jar file, in the automatic module, are exported. So, of course, it's not a really good module because good modules encapsulate some parts and export other parts. But it's all we got if we only have a jar file without a module descriptor. So this is a transition feature that you can use if your libraries aren't modularized yet, but your application code is modularized.
So one of the challenges with using modules has been around reflection because of encapsulation, right? A lot of code, like as you mentioned before, Spring will use for like dependency injection, will use reflection to be able to inject things, for example. You can't do that when you're across modules. So what are some of the challenges and solutions that you have to think through and deal with when you're using reflection in a module system?
So there's definitely a tension between how Spring uses reflection and between encapsulation. And what you see there is normally you would have a service interface and a service implementation, and you would want to hide the implementation and you would want to export the service interface to other modules. But then Spring itself is also just another module. It wouldn't be able to access the implementation of the service. And it has to, because it has to instantiate the implementation. It has to inject into some fields of the implementation maybe. So at runtime, Spring really needs the access. So what you can do there is use a feature called open packages or open modules in the module system. It's sort of a halfway point between full encapsulation of what modules offer and just being out in the open on the class path, which used to be the case in Java 8. So an open package is a package that can be reflected over at runtime. And this seems to break encapsulation because at runtime you can just access the implementation class and do stuff with it, like Spring, inject into the fields or instantiate it. But at compile time, you still cannot refer to types in an open package. This helps, of course, keep your own code clean. So you won't be able to instantiate the implementation type or to even know about the implementation type of a service. But at runtime, it will still be available to Spring. So open packages and open modules. An open module is just a module where every package is open by default. These are really useful when working with libraries like Spring or Hibernate that are making heavy use of reflection.
What about some of our build tools with Maven and Gradle? Are these all going to work as they were in 8?
Yeah, so using Maven and Gradle on JDK 9 to compile a code will just work. If you're talking about actually creating modules using Maven or Gradle, this will work too. At least in Maven, there has been support almost right from the start to create and compile modules. Gradle, on the other hand, does have some support, but it's an experimental plugin currently that you can use to create modules. So they're sort of behind the curve with respect to Maven.
Any other pitfalls on the path to migrating to 9 that are really common?
What also has happened is that the layout of the JDK itself has changed. So we used to have a big rt.jar file containing the whole runtime library. Well, obviously, this has been broken into modules, and these modules don't live in jar files anymore. They're in a runtime image file. And if your tools that you're using depend on this, then things may break. And the other thing that has also changed is the version string scheme. So usually before Java 9, the version string of Java started with 1 dot. So we had Java 1.8, 1.7, 1.6. With Java 9, they finally dropped the 1 dot prefix. So we now have version 9.0.0 or 9.0.1, which is great, of course, but it's not so great if your tools depend on the actual 1 dot prefix being available, which some libraries like Log4j, they actually broke on this. But that's fixed now, so if you upgrade to a later version of Log4j, then this won't affect you anymore. But these are the things that you don't really think about that deeply when you move to a new version of Java, but that turn out to be problematic in some cases.
So earlier when we were talking, you talked about the actual removal of APIs, that things aren't just deprecated, but they actually have been removed with 9. What are some of those, and why do you think that now's the time that Oracle decided to actually start removing APIs?
Yeah, so there are 6 methods, I believe, that have been removed in the Java 9 release, and many more have been marked as deprecated, but we're not talking about that. And these all had to do with the property change listener support. And this is something, property change listeners are part of the Java Bean specification. The point is that the Java Bean specification is part of the Java desktop module, which is kind of weird, but that's just a legacy that we have to live with. It's sort of embedded in the Java desktop APIs. But for example, a type like Java util logging log manager had an add property and a remove property change listener method, which works if everything is on one big class path, because who cares? But it doesn't really fit nicely if your log module in the JDK has a dependency on a desktop module, which is quite big and is all about AWT, swing, etc. So the Oracle JDK team decided to bite the bullet and to actually remove these methods to avoid a dependency from, for example, the logging module in the JDK to the desktop module. And I think this also nicely highlights the trade-offs that you have to make when you move to the modular world. Because the sneaky dependencies that are in your code base, they all work if you throw everything on a pile in the class path. But is it really good design if you have some logging implementation depending on types from a desktop API? That's a question that you should ask yourself. And they did that during the development of Java 9, and they actually decided to fix this, which is a good thing. But I think once people start moving to more modular developments, many of these sort of sneaky and really unnecessary dependencies start surfacing, and they will also point you to parts of your code base that have become entangled that should really be detangled.
There was initially a no vote from the Java Executive Committee on Java 9. One of the issues there was around the idea of like split packages, among some other things. Can you elaborate a bit on split packages and where that overall discussion kind of ended up?
The module system currently disallows split packages, right? So you can't have 2 of the same packages across different modules. And that sort of makes sense if they're exported from both modules, because, well, then you would obviously have a clash. But it's also disallowed currently in implementation if these packages aren't exported, which is a bit strange because, well, it's just internal implementation details. Who cares what the package is named like? So that's a discussion that has been on the EC as well. But in the end, that wasn't addressed. I think most of the discussion during the EC vote was about some features that, for example, JBoss wanted to be added to the module system APIs to make it easier for them to interoperate with Jigsaw.
Speaking of JBoss, one of the other issues that the EC originally voted down was other module systems and how it would work with Java 9. So JBoss modules or OSGI and how it might work with modules. What does that look like? What's that reality look like today?
We obviously still have the class path in Java 9, so you can still run OSGI on the Java 9 class path, and you can still use JBoss modules like before on the Java 9 class path. But if you want to move beyond that, if you say, okay, wouldn't it be nice, for example, if my OSGI modules could require Java system modules or the other way around, then there have been some experiments, mostly by the OSGI Alliance that I've seen. But these aren't really production ready yet, and there's no real story yet about interoperability between OSGI and the Java module system. So for now, they sort of coexist in the same sphere. So If you have an OSGI-based application, you're probably not going to rewrite it to Java modules. You just keep on running it on the Java class path. But if you start over from scratch, if you start a new application and you want to modularize it, then you still have a choice, of course, if you're going with Java modules or OSGI modules. And which way you go really depends on the features that you require from your module system. If you want something that's native to the platform, that's relatively easy to understand. I think Java modules are the first pick. If you really need all the dynamics of, for example, OSGI, so you can hot reload, start, stop bundles in OSGI. All the APIs are really centered around that, so they all support lifecycle callbacks and all these dynamics. Yeah, then definitely you should choose OSGI, because if you want to bolt that onto the Java module system, you have a lot of work ahead of you.
So what advice do you have for people that are considering moving to 9 on how to get started?
Like I said, when we talked about migration, the first step is definitely to just take your code and try to run it on the JVM of JDK 9. And you might run into issues, but you might also see that it just works. So if that's the case, lucky you. If that's not the case, definitely read up about all the changes that we talked about, because there's a lot of changes in Java 9. Also, it's not, I think, realistic to expect that most applications that currently run on Java 8 will be modularized. So I think the module system will really show its benefit for more new developments on the JVM platform. Fortunately, many of the libraries in the Java community are already adopting modules. So they have module descriptors for libraries. They are moving to a world where they're not depending on JDK internal APIs anymore. So that's good. So this will really help in the coming months and years to actually get us all to the modular world.
So what new changes or features do you see coming forward beyond Java 9 with the module system?
At the moment, there are no known JEPs, Java enhancement proposals, open regarding the module system. That doesn't mean that no work is done, but it's mostly polishing what's there. What I personally hope that will be addressed in the future iteration of the module system is versioning. As of now, the module system can record versions of modules, but it doesn't use the versions yet to do any checking or any resolution of different versions of modules. And to many people, that sounds a bit surprising, because most module systems do address versioning. But for the Java module system, they explicitly put this out of scope, because we have many build tools like Maven, Gradle, etc., and also other module systems like OSGI, which all do something with versions, which have different semantics, which have different resolution mechanisms, etc. And they just didn't want to put that yet into the JDK and into the Java language specification. So I sort of understand that, but at the same time, versioning and modularization, they logically go together. I hope this will become a part of the Java module system as well.
Yeah, I was really confused about that, and I asked Brian Getz specifically about that, and he just was kind of out of scope. Otherwise, we would still be working on Jigsaw and still trying to get 9 out, and it would have prevented us and been a blocker. But it does seem super confusing when you just look at it on the surface of modularizing the runtime, and all these different now modules don't have a way of specifically tracking versioning.
Yeah, so the story there is version selection is relegated to build tools like Maven and Gradle, and these should construct a module path for you, and then the Java module system can check the consistency in terms of module dependencies, but not for exact versions.
If you enjoy this chat, I recommend checking out Sandber's talk at KubeCon London this March 5th through 7th. His talk will also be posted online the weeks following after the conference, so if you can't make the conference, be sure to check it out online too. If you really like that, you can also check out his book, which he co-authored with Paul Baker, called Java 9 Modularity, and it is at javamodularity.com. Sander, thank you so much for joining us on the InfoQ podcast.
You're welcome. Thanks for having me.
As I mentioned at the start of this podcast, Sander and I recorded this podcast prior to the release of Java 10 that went GA on March 20th. So I thought I'd mention a few of the JEPs and changes that the release of 10 means to the Java developer for those of you listening. The first thing that really jumps out at me is that the release of Java 10, 9 appears to be obsolete. Ben Evans, InfoQ's Q editor, reported on this in a series of news articles where he said as of March 20th, the only versions of Java with free support from Oracle are Java 8 and Java 10. The next release with long-term support will be available is Java 11. That'll be released in September of 2018. Some of the features of Java 10 that were released include local variable type inference or introducing var, the experimental Growl JIT compiler, parallel full GC for G1, application class data sharing, and improved container support, and several other features. You can check out more about Java 10 by reading some of Ben Evans' reporting on InfoQ.com on Java 10. Thanks again for listening. We look forward to seeing you next time.
Good day, I'm Shane Hasty, and I'm the host of the InfoQ Culture Podcast, a software engineering podcast that looks at team leadership, product ownership, and a wide variety of culture-based topics. We've had recent guests, including Rich Murnov on product development trends, Wendy Clausen on mindfulness and effective communication, and Harsh Sinha on building culture at TransferWise. If you're in a leadership position or aspiring to get there, you might want to check it out. You can download and subscribe via the same place you found the InfoQ podcast, or find out more at infoq.com/podcasts.